welcome to your physics class. In the previous class, we discussed about the types of motion, namely translatory motion, rotatory motion, vibratory motion, oscillatory motion, periodic motion, non-periodic motion, and we also learned some of the combination of motions. Right? So in today's we briefly discussed about the simple pendulum. Let us derive let me give some definition related to simple pendulum. So we have learned about the simple pendulum. In this session, we are going to learn about that and a little more about the types of motion. So this is the setup of simple pendulum. So what is simple pendulum? Simple pendulum is a heavy point mass suspended from a rigid support with the help of a string called inextensible, flexible and weightless. Okay, so that is the nature of the string, and this bob, this one we call it as a bob made up of brass, metallic bob, okay, made up of brass, and this position we call it as mean position. If I consider this as B, and then here if I consider these two as A and C, so A and C are called extreme positions. So let us see some of the terms related to simple pendulum. So the length between this point is called point of suspension. And this support is called rigid support. And this point is called point of oscillation. Now let's see some of the terms related to simple pendulum. So mean position is the position of a pendulum when it is at rest, and extreme position are the position of a bob when they are moving. The extreme position of a pendulum. Okay, and the gap between or the length between the point of suspension and point of oscillation is called length of a pendulum. Okay, so this is about the parts of the simple pendulum. So based on this, we can learn some of the terms. The first one is amplitude. What is amplitude? Amplitude is the maximum displacement produced by a bob from its mean position. Okay, or the distance between the mean position and the extreme position is called amplitude. And the SI of amplitude is meter, because we are measuring the length. And second one is time period. And before that, we should know what is the oscillation. The oscillation is nothing but one complete to and fro motion of a bob. Complete to and fro motion of a bob about its mean position is called oscillation. Okay. And how much time it takes to complete one oscillation is called time period. They represent by the letter capital T, and the SI unit is second. And the next one is frequency. They represent by the letter small f. Frequency is the number of vibrations produced by a vibrating body or by a bob from in 1 second. For 1 second, how many times it oscillates, that is what we call it as frequency. They represent by the letter F, and the essence of frequency is hertz. So you can just compare the definition of time period and frequency. They are opposite of each other. They are reciprocal of each other. So that is why we can write out the relation between F and T as F is equal to 1 by T or T is equal to 1 by F, because both of them are inversely proportional to each other. And the next one, amplitude, time period, frequency, vibration. Yeah. So these are some of the terms related to simple pendulum. And we have learned all types of motion. Again, all these type of motion we can classify them again into two types. So let us see what are those two types of motion. etc. And even any vehicle moving with a constant speed is an example for uniform motion. And then what are the examples for non-uniform motion? Bouncing of ball. See, when you start bouncing, after some time what happens? It reaches different height. Okay. And if a person is moving the long run, like 300 meters, 3 kilometers and all, so the person will not move with a constant speed. He will keep on changing. Even 100 meter. Why do you go to 3 kilometers? Even if you consider 100 meter, the runner or athlete will not run with a constant speed. Okay, they will be moving with a different speed. So that is also example for non-uniform motion. So all these are about uniform and non-uniform motion. Now let's learn a very important thing that is very useful and is not very useful. So please listen carefully. That is about distance and displacement. As I have told, distance is nothing but a length. So length means it is a gap between 2 points. Okay, but we can also define the length with different terms that we have already discussed. Let's learn a little more about it. So what is this distance and what is displacement? Are they same or different? Actually, both of them are length. Okay, we are measuring the gap between 2 points. Both. But they are not equal, they are different. So, to understand that, again I will take an example. Suppose if a person is moving from A to B. If this is 10 meter and if we compare to C, if this is 3 meter, so what will be this one? This is 7 meter. Now my question is, suppose first let me tell you what is distance and displacement. Afterwards I will explain that example. So distance is the actual path followed by a body between 2 points in which it travels. Okay, so you should consider how it has gone, how much distance actually the person has traveled, or the vehicle or any body is traveled. But what is this displacement? Displacement is also a gap between 2 points, but the difference is displacement is the shortest distance between initial point and final point. Okay, you should always measure the shortest distance between initial and final point. So even though the person has traveled a long route with a long road, but you should consider only the shortest distance between initial and final point. That will give displacement. And if you have 2 points, the shortest distance is always the straight line between 2 points. If you turn those 2 lines by a straight line, that straight line will always give you the displacement. Okay, so that is what we call it as displacement. Now with this example, let us learn more about distance and displacement. Usually distance is denoted by the letter small d and displacement by capital D. Suppose when a person is moving from A to B, what is the distance traveled? Distance is 10 meter. Displacement is also 10 meter. And whenever body is moving from A to C, distance is 10 plus 3, 13 meter. Displacement is this much. How much? It is 7 meter. And A to A is when it comes back to the same position. Distance is 10 plus 10, that is 20 meter. But displacement, there is no gap. It has come back to the same position, so it is 0. So this is how we can able to measure distance and displacement. So from this we can able to consider, we can compare the difference between distance and displacement. So distance is the actual path followed by a body between 2 points, but displacement is the shortest distance between initial point and final point. And if you observe, in all the 3 cases, or you can take more examples, in all the cases you can see that distance is always increasing with the time, but displacement may decrease with the time, with increase of time. See here it has decreased when it's coming back to the same position. Okay, and one more thing, compared to displacement, distance is always more and it can be even equal. So distance is always greater than or equal to displacement, but displacement is always lesser than or equal to second. And but for vehicles and all, these are very small units, so we can't able to measure the speed of vehicles using meter per second and centimeter per second. So in that case, what we'll do, we'll measure the distance by, we use other units. So in that, the distance we measure it in kilometer and time in hour. So in this case, the unit is kilometer per hour. So you can write like this. So that's nothing but kilometer per hour. So don't use this symbol. So use this one. And if you measure the distance in miles and time in hour, so unit is miles per hour. You write for miles, you should not use m because we have already used m for meter. So you should write it as miles itself. Miles per hour. But the short form for this is kmph and miles per hour is mph. They are not the units. They are the short form of kilometer per hour and meter per hour. Sorry, miles per hour. Okay. So these are the units. As I said, they are measured. Speed is measured with a different unit. All of them are not equal. So let us see what is the relation between those units. Especially mainly we discuss about kilometer per hour and meter per second. How these two are related to each other. So in order to find out the relation, first you should consider the bigger one and you should solve it. So what is it out of these two? Kilometer per hour is the bigger unit. So I'll take 1 kilometer per hour for 1 unit we should take. Okay. And this can be written as according to the formula, distance will be equal to 1 kilometer and time will be equal to 1 hour. So in 1 kilometer we need to find the relation between kilometer per hour and meter per second. So 1 kilometer is equal to how many meters? We know that it is equal to 1000 meters. And in 1 hour there are 3600 seconds. So if you want right side you can write, because 1 kilometer is equal to 1000 meters and 1 hour is equal to 3600 seconds. Because in 1 hour we will have 60 minutes and in each minute will have 60 seconds. So 60 into 60, 3600. So here I can write out this 2 1s are 2 8s are. Here 2 5s are. So I got 5 by 18 meter divided by second. I can write that as meter per second. So I can write 1 kilometer per hour is equal to 5 by 18 meter per second. So this is the relation between SI unit and CGS unit of speed. And next one, suppose if a body is moving with a non-uniform motion, I told the speed will not remain same. It will be moving with a different speed. So in such case, we will find average speed. So what is this average speed means? Average speed is also a ratio. Like how I have written in the same way, you can write. So average speed is a ratio. It is a ratio of total distance traveled by a body to the total time taken to cover the total distance. That is how we can write. So suppose example, I will tell you the example. And here also remember the SI unit, CGS unit, other units are same as speed because our speed is also ratio of the distance and time. So they have same unit as speed itself. So which means how we will calculate? Suppose if the body is moving from this point A to B next class. I hope it's clear. I have uploaded the assignment in the Google Teach Me tab. Please write down and submit to the school. Thank you, children.